So now let's go through the test of this Anchor program line by line. First of all, we are importing all of the dependencies. We're importing Anchor from Coral XYZ. Thereafter, we are also importing the program from Coral XYZ only. Thereafter, we are importing our counter PR from the target types counter PR. And then we are importing the key pair of from the Solana web3.js. Right. Thereafter, we are establishing a provider through the anchor with the help of the anchor library anchor.anchorprovider.env, and thereafter we are just setting up that provider, and then we are initiating our program through anchor.workspace.counter as program counter PR, and then we are just generating a new key pair for a counter account in which the storage of counter can be stored. And then we are initializing a test using it keyword, and we are just saying is initialized. We are using async function, and we are just generating the transaction signature using program.methods.initialize.accounts counter account.public key. We are just giving the signer and RPC with the accounts to fetch the transaction signature from the program. Now what we are doing here is we are declaring a variable account data which fetches the counter from counter account.public key. Right. At last, we are just printing out the transaction signature and the value of count. And then we are generating another test of increment. We are just using the increment function that we we are just using the increment instruction that we developed in the lib.rs file, and we are giving it as counter account.public key. And lastly, we are just fetching the value with the help of counter account.public key, and then we are printing it out. Right, so that's all what we are doing in this test file. We can just go ahead and run this test, and thereafter we'll be output it with this. We'll be getting the value of count, increment, and we'll get two tests. Those are passing. You can do it by yourselves. We are going to move ahead with finalize your Anchor program with a PDA. The PDAs are program derived addresses, which basically are accounts that are controlled by the program with an address that you can derive from a combination of known items, a seed, and the program ID. The data stored in PDA is secure because only the program can change it. Now, instead of having to keep track of and manage a key pair that stores the data, we can just use a function that derives PDA for us. This is how we can derive a PDA. We can just use the public key of the program, and then we can use .find program address sync function, and we are passing the buffer of counter in it that acts as the seed, and then we are passing the program ID of the program. This is the new method of deriving the PDA, and there's also the old method in which we are just declaring the new key pair on the variable count account. In this, we have to keep track of this value. It can't easily be shared with others, and it have many security concerns. If the key pair is leaked, anyone can change the value. Right now, the final bit of a PDA is bump number. This is an extra item that is used to make sure the generated address does not have a private key. So you find a PDA using program ID seed bump. Right, here's what the updated code in our lib.rs file will look like. Here we have just used the bump and initialized in the context using the context.bumps.counter, and we are just printing it using counter.bump. So that's we have done. And here we have also passed seeds and bump in the account for deriving the PDAs. Right, here too we have passed the seeds and bump in the counter variable to derive the specific PDAs for that. Now make sure you run anchor key sync here. If you have copied pasted everything, we'll need to make sure you have seeds enabled as an anchor feature. So we can open our anchor.toml file and set the seeds to be true in the features section like this. So that's all, and we have also updated our test like this for just declaring the PDAs as mentioned above. We are just passing the PDA as counter PDA and just printing out those transaction and account data.count. Now though we have made it this much changes in our program, so our program is more than double the size of the original. So if we run anchor test script local validator, we can get the errors. You know, the size error that simulates the total size. So we just need to extend the size of the old program. So we are just using the local net and we have enough Sol in our account, so we can directly extend the program's size. You know, firstly we can use this command Solana program show. Thereafter we can use the program ID for which we are increasing the size, and then we will get these informations: program ID, owner, program data, authority, last deployed, data length, and balance. To find out the size of the new program, we can run this command du-h, and then we can pass the counter.so file from the deploy directory from the target directory. This will print the disk usage of the compiled program. So if you want to find out how much Sol this will cost, you can go ahead and run this command. After that we have found that how much Sol it's gonna be costing, we can just go ahead and run this command Solana rent. After that the size, so we can use this command Solana program extend with the program ID and the size, and thereafter we can easily deploy our program, right? We'll need to set our, let me clear this console. For this we'll just need to set our configuration to the Devnet. As we can see, we have done this. Now I'll just airdrop some Sol into it. Yep, I have 4 Sol in my balance, so I can easily run it. Now we are ready to deploy our program to the Devnet. If wanted, we'll need to update our anchor.toml file, then we'll need to deploy our program to the Devnet, and then we can return the test to initialize our program and increment the counter, right? So we'll just go ahead and check to deploy it, right? If we want to deploy it to the Devnet, we just need to change this cluster to the Devnet, from localnet to the Devnet. It will automatically get this registry URL and all of that, right? So after configuring our cluster to Devnet, we'll just head over to command prompt and run anchor deploy. We should have the Devnet Sol for it. We can airdrop them as told earlier. And here we can see our program ID is this, and our deployment is success, right? We can just go ahead and search it on explorer.solana.com, and here is our program. This is our program account. We can see the balance, everything, executable data. This is all of the history. You can go to this transaction and we can see program return success, right? So that's how we can deploy our program to the Devnet. And if the program deploys failed, we can run the buffers. We can show the buffers. Why is it failed also? If we have run out of the gas, we can just close the programs which we have previously deployed, so that our Sols can be possible, right? Now guys, that was it for today's session. In the next part, we'll delve into how we can build a React client for our app. We'll just use this program and connect it with our React client. So until then, happy coding.